Hey, so today we're going to be discussing why physics is so fun.
And it really is cool, trust us.
So, my name is Brian Seymour, and I'm a physics major at University of Virginia. And ever since I was in middle school, I became really interested in how the natural world works and how we can understand it through physics.
And my name is Luke Opp, and I'm actually a chemistry major, but chemistry actually deals with a lot of physical properties. And actually, when I was younger, at our elementary school, we saw a lot of chemistry demos being done, and it was just really cool being able to visualize how certain chemicals reacted and seeing things work. And so I thought that it would be really cool if we could show you guys some demos that involve physics to see if that would get you interested in it.
So, our goal here is to discuss why physics isn't scary, but it's actually really fun. Because I remember back before I started learning a lot about physics, I was very intimidated by it, and I feel like a lot of other people kind of have some of the same thoughts. So our goal is to break through that and see and explain and show why physics is just fun at its core.
You used to be intimidated. I still am intimidated, but I just want to let y'all know that even though it might seem scary with all the concepts and all the equations that are presented within, once you start studying it and you realize that all of those actually relate to one another, it's really not as bad as it seems. Alright, so now we're going to talk to you about the importance that physics actually has, and it might be a little bit upsetting to hear, but America is not doing as well as we think we are in science. Brian, how about you read them some statistics we found?
So in a Pew Research study of early high schoolers, the U.S. ranked 35 out of 64 countries in their science abilities. So, and this is very problematic that we're not being up to par.
The reason why this is actually problematic is because physics is used for more than just watching an apple fall. It's used to describe different properties involved with machines and how they move. It's used to study how blood flows throughout the body. And it's also used to show how rockets can go into space.
Yeah, and over the next 10 years, a Department of Commerce study found that the jobs in STEM fields, or science, technology, engineering, and math, are going to grow at twice the rate as the other fields combined. So knowledge in physics and science is very important.
So there is hope for job prospect. So there's going to be a lot more need for people to know about science and technology. So we're going to try and get y'all excited today by showing you some really cool demos. Alright, so we're going to talk about some really important aspects of physics that will be in just about anything that has to do with the world. We're going to talk about force
and momentum.
Alright, would you like to explain what force and momentum are?
Okay, so momentum is the tendency of an object to either stay like still or to move without stopping.
And how do you get them to move?
So the way that this happens is if you apply a force, it changes the momentum. And a force is normally just like a push or pull. So if you have like a stationary object and then you push it, it causes it to start having momentum. So to demonstrate this, currently Luke has no momentum in any way.
I'm just standing here.
If I apply a force, he has a momentum in that direction.
Alright, so now we're going to show you just how cool physics can be by showing you guys some really nice demos.
To the lab! So the first thing we're going to talk about today is the force of gravity. Now this is something that all of you are very familiar with. It's the thing that when you jump up, it causes you to be pulled back down to the ground. Because initially when you jump, your momentum is going up. The thing that causes you to be pulled down is the force that pulls you back down. So the thing we're now going to investigate is how fast do objects fall? So I have a really heavy basketball in comparison with the tennis ball, and we're going to see which one falls faster when I drop them. So I'm dropping them at rest, so they have no momentum at the beginning, and the only thing that changes their momentum is the force of gravity. So you'll see in slow motion replay, they both land at the same time. So the reason that this happens is this ball is heavier, so it requires more force to pull it down to hit the ground. And the thing is the force of gravity pulls harder on heavier objects. So in the end, the mass of the basketball is canceled. So and the effect is that the weight of the object doesn't affect how fast it falls. Each object falls at the exact same rate.
Hello everybody. As you just saw my partner perform, he showed what happens to an object when you release it from rest. A force of gravity acts on it, dropping it to the earth. And as you see, it bounces back up. But why exactly does it bounce back up? Well, what happens is a force from the earth acts in the opposite direction, sending it back up. And this is actually the momentum that acts on the ball. But what happens if we take our tennis ball, which doesn't really bounce too high, and we put it on top of the basketball? In theory, this should make the momentum that's acting on the basketball act on the tennis ball by having the momentum surge through both at the same time. So, how about we take a quick look? And as you see, that was a lot higher than our first attempt. When it hits the ground without the basketball, it barely bounces to my knee. But it's experiencing a force of momentum that is a lot stronger than originally anticipated, because it's not just its own, it's also the basketball's. Hello. So, the demo that we have set up for you looks pretty elaborate, doesn't it? We have a glass bottle, we have a wooden hoop, we have a pencil. So, what I actually want to show you guys is that I can get this pencil inside that glass. Alright, you want to know how I do it? Okay, so all three objects are initially at rest. So, in order to get the pencil in there, I pull away the ring. Now, I pull the ring away so fast that no force is acting on the pencil. So the only thing that's causing its momentum is gravity. So when I remove the ring, it just falls straight into the glass.
So just earlier, like when we were talking about how things tend to keep going in the same direction because they have momentum. Like when we have this ball, it just keeps rolling that way because of its momentum forward. The same momentum also applies to turning. So I'm going to show you. See when I turn like this, I keep turning because I have rotational momentum. It's a little bit different than the normal type of momentum, but I have that property to keep turning around unless I apply a force by stopping myself on the ground. So the rotational momentum is a lot more different than normal momentum now. I'm going to demonstrate this by holding two weights. When I rotate with these two weights, I'm going pretty slowly, but what matters is how close these weights are to me. So when I got these weights closer, I became more condensed in a small place because all near where I'm rotating. And this is the same thing that causes, like my rotational momentum had to stay the same when I got into a smaller area. So you can use this when you're at a merry-go-round on a playground to make yourself rotate faster.
Alright, so today I'm going to show you exactly what our rocket is going to consist of. Alright, as you can see, this is it. It's just a simple 2-liter soda bottle. And what we have in there is what we call dry ice. Now, what exactly is dry ice? I'll show you. Dry ice is basically solid air. As you can see, it's turning into gas or air without even turning into a liquid. Now, how is that really going to work in our rocket? Well, this is where the chemistry side for the physics comes in. What we're going to do is we're going to add water into our 2-liter rocket, and it's going to cause all of that dry ice to evaporate instantly into air. And that air is going to build up inside, and it's going to become the upward force that sends it into the sky. So how about we take a look, shall we? So make sure you're like... Whoa.
If you look, you can see how it's very cloudy. That's because all the CO2 that was released through the dry ice, and also water vapor through when the rocket went off. So what happened in that experiment that caused the bottle to raise up and fly up into the air? Just as Luke earlier talked about how pressure was building inside the bottle because all the dry ice turned into air. When the cap came out, the water was pushed downward by a force because of pressure. So and one of the things that is a law of forces is every force has an equal and opposite force. So what actually happened was the bottle itself had a force upward because there was an opposing force. And this force is what we call thrust. So as the water came out, the bottle was pushed up, and that's what caused it to go 50 feet in the air.
Alright, so we saw that the rocket was able to actually lift by expelling the pressure through a loose seal created by the cork. But what happens if we make a tight seal and none of that air or pressure is able to leave?
Alright, so this is our last experiment. So since there was nowhere for the pressure to escape because there was no cork in the bottom, it just kept building up until it reached a certain point where it actually tore the plastic apart. And once that started happening, the bottle just exploded into mini pieces.
Okay, so today we covered some really scary topics. I mean, we talked about force, we talked about momentum, we talked about pressure, but trust us, it's really not that bad.
I hope you guys had a ton of fun learning about how do the things in the physical world move and work. And it's really fun to just like to finally understand what's going on around us. I also have some recommendations for you guys. Bill Nye the Science Guy, Physics Girl, Veritasium, SciShow, Minute Physics, and Brain Pop. These are YouTube channels that you can go to with your parents and see some very elaborate experiments to help understand. So we're gonna end by just in the credits you can see all the funny things that we did along the way.
Yeah.